In today's class, we'll be solving more examples on longitude and latitude, where we'll be solving 3 examples on longitude and latitude. And the first example says X and Y lie on the same meridian. Their latitudes are 15 degrees north and 36 degrees north. Find the distance XY measured along the meridian. So X and Y lies on the same meridian where their latitudes are 15 degrees north and 36 degrees north. Now we need to find the distance XY measured along the meridian. Now to solve this, what is the first thing that we are going to do? We are going to subtract these degrees from each other. We are going to subtract these latitudes from each other. So we have it to be 36 degrees minus 15 degrees. So we have it to be 21 degrees north. So using our formula, which is theta over 360 times 2 pi r, we have it to be 21 over 360 degrees times 2 times 22. Okay, we can just write it here like 21 over 360 times 2 times 22 times 6,400 times 7. So 7 here 1, 7 here goes here 3. We have 0 here and we have 0. We have 3 here 1. We have 12. We have 2 here to be 6. We have 2 here 11. We have 2 here 1. We have 2 here. We have 3. So we have it to be 11 times 640 over 3. So 11 times 640 over 3, we have it to be 7040 divided by 3. And solving this, we have it to be 2346.6 kilometers, where we can round it up to be 2347 kilometers, or to 2 significant figures, we have it to be 2,400 kilometers. 2,400 kilometers. So that is the distance XY measured along the meridian. Now, the second example for today, we have it to be that 2 places S and T have the same longitude. That their latitudes are 15 degrees north and 36 degrees south. We have to calculate the great circle distance ST, which are the 2 places. We have to calculate the great circle distance. Now, it is important to know that a simple trick where we can have is that once we have 2 different locations where we have one to be north and one to be in south, we add the latitude or the longitude together. But when we have separate one, we subtract them. So the separate latitudes are usually subtracted, while different latitudes are usually added together. Different latitudes are usually added together, while the ones that are not different, that are the same, are usually subtracted from each other. So here we have it to be 36 plus 15, and 36 plus 15, we have it to be 51 degrees. So using our same formula, we have it to be 51 over 360 times 2 pi r. Then we have it to be 51 times 2 times 22 times 6,400 over 360 times 7. So when we multiply this, we have 0 here 0, we have 2 year 1, we have year 1. In 16, we have it to be 8. 2 year is 11, here we have it to be 9. So we have over 63, and we have 51 times 11 times 640. We have it to be 359040. And when we solve this using our calculator, we have it to be 5690.4. We have it to be 5690.4, and approximating it, we have it to be 5,700 kilometers. We have it to be 5,700 kilometers. And the third example for today, we have is that P and Q are two places on the equator. Their longitudes are 173 degrees east and 75 degrees west. We have P and Q. Here we have 173 degrees east and 75 degrees west. So what is the shortest distance between them along the equator, and how far is Q from the South Pole? Now, the shortest distance between the equator, what do? They are separate. So we have the short distance between them. So you have to look for the shortest distance. What do? We do 360 degrees minus 173 degrees plus 75. So we have this to be 360 minus, we have 8. This is 4. And we have 2. So 360 minus 248, we have it to be 112 degrees. We have it to be 112 degrees. Since this equator is already going towards the upper part, in which we are looking for the shorter distance between P and Q. So we have it to be 112 over 360 times 2 pi r. So we can easily have it to be 112 times 2 times 22 times 6,400 over 360 times 7. So here, if we cut this, we'll have to be 0. We have 2 year 1. 2 year is 18. We have 2 year 11. We have 2 year to be 9. We have 2 year to be 9. So when we solve this further, we have it to be 112 times 11 times 640 over 9 times 7. And when we solve this further, we have it to be, using our calculator, we have 12,516 kilometers. Now, to round it up to two significant figures, we have to be 13,000 kilometers. We have it to be 13,000 kilometers. Now, the second question says, how far is Q from the South Pole? How far is Q from the South Pole? How far is Q from the South Pole? Now, using our diagram where we have this, we have our middle point. From here, which is our South Pole, we have our Q to be this part here. So here is our Q. So from our Q to our South Pole here, this is our P. Okay, this is our North Pole. Our P is around this side. where here is 173 and here is 75. Since one is between east and this one is between west. So here, how far is our Q to S? Our Q to our south pole. So from our Q to our south pole, we have it to be 90 degrees over 360 times 2 pi r. So we have it to be 90 over 360 here is very 9 here is 1, 9 here is 4. So we have it to be 1 over 4 times 2 times 22 over 7 times 6,400. So 2 here 1, 2 here 2, 2 here 1, 2 here 11. So we have 11 times 6,400 over 7. And solving this, we have it to be 10057 kilometers, where we also have it to be 10,000 kilometers. So the distance of Q from the South Pole is 10,000 kilometers. And this brings us to the end of our class on more examples on distances along the Great Circle, where in our next class we'll be talking about distances along parallel of latitude. Subscribe to our YouTube channel, like and comment, and I'll be seeing you in the next class. Thank you.